Welcome back to my class in Mathematics in the Modern World. For today, we will start up with a brand new lesson called Transportation Problem. Like the simplex method in linear programming, the solution of a transportation problem requires an iterative process. That is, the method used to solve transportation problems is an iterative method, which means that we go through the same process repeatedly until we meet the criteria that indicates that the solution has been completed and that the optimal solution is obtained. In transportation problem, we have two sets of individuals given. The set of individuals or entities or organizations or companies that make the demand. And the second set of suppliers, each with certain amount of supplies that will satisfy the demand of those individuals or entities that made the demand. And all the information needed to solve a transportation problem are presented in tabular form or in a table such as this one. This is the tabular presentation of a transportation problem. All the information needed to solve a transportation problem are presented in table like this. As I said, the first set of information is the set of demand, that is demand that is made by group of individuals or entities or organizations or companies. In this example, those entities or individuals that make certain demands are denoted by A, B, C. The demand of A is 87 units. The demand of B is 124 units. The demand of C is 95 units. The second set of individuals or information given in a transportation problem is the set of supplies. And in this example, the suppliers are denoted by X, Y, and Z. The number of units available or the available supplies for each of these suppliers are given in the last column of this table. Written supplies. Supplier X has 78 units in its warehouse. And supplier Y has 135 units and 93 units are available in supplier Z. The third set of information given in a transportation problem are the costs per unit of transporting one unit from supplier to demand or to the person who makes the demand. And we call these numbers at the upper right hand side of each cell. These numbers are called cell costs. The cell cost of 10 means that the cost of transporting one unit from supplier X to customer A is 10 pesos per unit. The cell cost of 7 means that the cost of transporting one unit from supplier X to customer B is 7 pesos per unit. And 9 here means that the cost of transporting one unit from supplier X to customer C is 9 pesos per unit. And 9 here is the cost of transporting one unit from supplier Y to customer A. And 12 pesos here means that the cost of transporting one unit from supplier Y to customer B is 12 pesos per unit. And the cost of transporting one unit from supplier Y to customer C is 8 pesos per unit. The cost of transporting one unit from supplier Z to customer A is 6 pesos per unit. The sub cost of 11 means that the cost of transporting one unit from supplier Z to customer B is 11 pesos per unit. And finally, 13 means that the cost of transporting one unit from supplier Z to customer C is 13 pesos per unit. The problem here is where to get the demands. From which of the three suppliers should these demands be obtained such that the total cost of transporting the supplies to the customers is minimized. That is, our objective in solving transportation problem is to minimize the total cost of transportation. Or our objective in solving transportation problem is minimization of transportation cost. Now, there are two types of transportation problems. Again, there are two types of transportation problems. The first type is known or called balanced transportation problem. The balanced transportation problem can occur in only one way, and that happens when the total demand is equal to the total supply. Again, the balanced transportation problem occurs when total demand equals total supply, or the transportation problem is said to be balanced when the total of the demand is equal to the total of the supplies. In our example of transportation problem presented in this table, let us check if this is a balanced transportation problem by getting the total demand and getting the total supply. If the total demand is equal to total supply, then the given transportation problem is balanced. To get the total demand, we add the demand of A and the demand of B and the demand of C. We have 87 plus the demand of B, 124, plus the demand of C, 95. And you may use your calculator to get the sum of the demands. We have 87 plus 124 plus 95. And we get 306. Now we get the total of the supplies by adding the supply of X, the available supplies of Y, and the available supply of Z. We have total supply equals available supply of X, 78, plus the available supply of Y, 135, plus the available supply of Z, 93. And we add using our calculator. We have 78 plus 135 plus 93 equals 306. Since the total demand of 306 is equal to the total supply of 306 units, we conclude that this given transportation problem is a balanced transportation problem. We write since or because total demand is equal to total supply, we conclude that the given transportation problem TP is balanced. If the transportation problem is not balanced, then we say that the transportation problem is unbalanced. The second type of transportation problem is called unbalanced transportation problem. And unbalanced transportation problem can happen or can occur in two ways. The first way by which unbalanced transportation problem can happen is when the total demand is greater than or more than the total supply. Or you may read from the right, total supply is less than total demand, or total demand is greater than total supply. That's one way by which unbalanced transportation problem can happen. The other way, or we say case 2 of unbalanced transportation problem, happens when the total demand is less than total supply. Or if you read from the right going to the left, the second case of unbalanced transportation problem occurs when total supply is greater than total demand. The method for solving the balanced and unbalanced transportation problems is the same. The process is the same, but when you solve unbalanced transportation problem, you first have to make it, you first have to balance it. You have to convert it to balanced transportation problem. So, if you are given a transportation problem before you proceed to solving it, you have to check first if the given transportation problem is balanced transportation problem or unbalanced transportation problem. If it is a balanced transportation problem, then you can go ahead and solve it. But if the given transportation problem is unbalanced, you first have to balance it before you proceed with your solution. But for today, we will start with solution of balanced transportation problem. But for today, we will only do up to setting up the initial distribution plan. The method for solving transportation problems is called stepping stone method. It's called the stepping stone method because we will be moving from one cell to another cell. It's like we are stepping on these cells, moving on from one cell to another cell. And for each table, there is a corresponding transportation plan. If the given transportation table is balanced, then this table becomes the initial transportation table. If the given transportation table or problem is unbalanced, you have to construct a new transportation table that is balanced, and that balanced transportation table becomes your initial transportation table. If the given transportation table like this is balanced, that is the total demand is equal to the total supply, then your table, the given table becomes your initial transportation table. Since we have already checked that this is a balanced transportation problem, that is the total of the demands is equal to the total of the supplies, then this given table is our initial transportation table. This is now our initial transportation table. Now we proceed with the stepping stone method, step 1. The first step is to distribute the supplies among these three customers A, B, C with these certain demands. The first customer is A, and we satisfy the demand of the first customer. Always begin with the first customer. The customer written at the left hand side. You satisfy the demands of the customer from the left going to the right. So we start from customer A. We satisfy first the demand of customer A. And customer A requires 87 units. Now, the supply to be delivered to customer A will always come from the first supplier. We will get the demand of A from the first supplier. The demand of A is 87 units. and the supply of supplier X is 78 units. That is, the demand of A is more than what supplier X can give, because supplier X has only 78 units. That means we cannot get all the 87 units demand of A from the first supplier X that has only 78 units. If the demand of A is less than 78, then you can get all that demand of A from supplier X. If that demand of A is less than 78 units, but the demand of A is more than 87, is more than 78, the supplies of supplier X. So what you do, you give all the 78 available unit supplies of supplier X to customer A, and you write 78 in this cell. So we have given all the supplies, available supplies of 78 of supplier X to the first customer A. But customer A requires or needs 87 units. But if it receives only 78 units, thus the demand of A is not fully satisfied. And A requires how many more units? 87 minus 78 is 9 units. Again, customer A needs an additional of 87 minus 78 or 9 units. But we have already given all the supplies of supplier X to A. So what we will do, we will get the additional 9 units from the second supplier. And you write 9 in this cell. Now we have fully satisfied the demand of A of 87 units. 78 will come from supplier X. 9 will come from supplier Y. 78 plus 9 is 87. Now customer A is fully satisfied. But supplier Y has available unit supplies of 135 units. But we have already given 9 units to supplier A. So how many more units remain in supplier Y? The number of units remaining in supplier Y is 135 minus 9. And you can use your calculator to get the difference. 135. You are allowed to use calculator. 135 minus 9. The difference is 126, which means that 126 units is the number of units remaining in supplier Y after delivering 9 units to customer A. Now, these 126 units will be given to the next customer B. The number of units remaining in supplier Y will be given to customer B. The number of units remaining in supplier Y is 126. 135 minus 9 is 126. And it will be given to supplier B. But supplier B requires only 124 units. Thus, you will not give all the remaining 126 units in supplier Y to customer B, because customer B will only requires 124 units. So what you will do, you take only 124 from the remaining 126 in supplier Y. You write in this cell 124 units. Now we said that 126 units remain in supplier Y after we deliver 9 units to customer A. But now we have given 124 units to customer B from 126 remaining. That means only 2 units now remain in supplier Y, or 135 minus 124 minus 9 equals 2. 2 units remain in supplier Y. And because we have fully satisfied the demand of customer B, the remaining 2 units will be given to customer C. And customer C requires 95 units. Now we will give 2 units to customer C to come from supplier Y. And we write in this cell 2. Now, nothing remains in supplier Y because the total of these 9 units delivered to customer A plus 124 units given to customer B plus 2 units given to customer C, the total is 135 units. And the demand of A is fully satisfied. 78 plus 9 is 87. 124. Demand of B is fully satisfied. 124 will come from supplier Y. And customer C, they requires 95. Now it receives 2 units. So it means an additional of how many more units? 95 minus 2, 93 units. But we have we have used all the available units of supplier Y. So the additional 93 units of customer C, we will get from the third supplier Z that has exactly 93 units. Now you can check from your table if your answers are correct, if your initial distribution is correct. You add the numbers vertically, 78 plus 9, and this is nothing. A vacant cell is considered to have 0. 0 plus 9 plus 78 equals 87. 0 plus 124 plus 0 equals the demand, 124. 93 plus 2 plus 0 is 95. You also add the numbers horizontally, and the sum of the numbers in the cells should be equal to the supplies for each supplier. For supplier X, we have 78 plus 0 equals 78. For supplier Y, 9 plus 124 plus 2 equals 135. And this vacant is considered 0 plus 93 equals 93. Therefore, this is a correct distribution, initial distribution. And after you have done the initial distribution, we now develop what is known as the initial distribution plan. This is the distribution plan corresponding for the initial distribution table, initial transportation table. Similar to the simplex method, for each simplex tableau, there is a corresponding solution. In transportation problem, for each transportation table, there is a corresponding distribution plan. And for the last transportation table that will give us the minimum or the lowest total transportation cost, we will call the distribution plan the optimal or the best distribution plan. Now we develop the initial distribution plan based from the initial transportation table. In the initial distribution plan, we have 5 columns: supplier, demand, the number of units to supply from supplier to the demand, the person or entity or company or organization that makes the demand. The cost per unit, that is the cost of transporting one unit from supplier to the demand. And the total cost of supplying this much number of units from the given supplier to the demand at the given cost per unit. You only consider the occupied cell. 78 means that we supply 78 units from supplier X to customer A at a cost of 10 pesos per unit. We write in the table supplier X from supplier X to customer A we supply 78 units and the cost per unit is given by this cell cost. The cost per unit of transporting one unit from supplier X to customer A is 10 pesos. Now, if the transportation cost per unit is 10 pesos, and you will supply 78 units, the total cost of transportation for 78 units is 78 multiplied by 10. That's 780 pesos. Next, we consider this occupied cell. 9 means we supply 9 units from supplier Y to customer A. And from supplier Y to customer A, we supply 9 units. And the cost per unit of transporting from supplier Y to customer A is 9 pesos. And the total cost of transporting 9 units from supplier Y to customer A at 9 pesos per unit is 9 multiplied by 9 equals 81 pesos. Next, we have 124. Only consider the occupied cells. This occupied cell has 124, which means we supply 124 units from supplier Y to customer B. Y to B, we supply 124 units. And the cost per unit of transporting from Y to B is given by this cell cost 12 pesos. And for the total cost of transporting 124 units from supplier Y to customer B at 12 pesos per unit, we multiply 124 by 12. We have 124 multiplied by 12. And you should get 1,488. Next occupied cell is this cell with 2 units. That means we supply 2 units from supplier Y to customer C. We give 2 units at 8 pesos per unit. We have Y to C, supply 2 at 8 pesos per unit. the total cost of transporting 2 units from supplier Y to customer C at 8 pesos per unit is to multiply by 8, 16 pesos. And the last occupied cell is this cell with 93 units, which means that we supply 93 units from supplier Z to customer C. And the cost of transporting 1 unit from supplier Z to customer C is given by the cell cost of 13 pesos. We write Z to C we calculate the total cost of transporting 93 units from supplier Z to customer C at 13 pesos per unit by multiplying 93 multiplied by 13. We multiply 93 multiplied by 13. And you should get 1,209. Now you add the entries in the last column, 780 plus 81 plus 1,488 plus 16 plus 1,209. And the total is your initial transportation cost. It is the transportation cost corresponding for the initial transportation table. And it's the transportation cost for the initial distribution plan. We add, we have 780 plus 81 plus 1,488 plus 16 plus 1,209, and you should get 3,574. The total of these entries is 3,574, and that's only the initial transportation cost. In the succeeding transportation tables, you will notice that this will get smaller and smaller until we get the lowest transportation cost. And this is the transportation cost that we will try to minimize. And the next step is for us to know if we can still make this total transportation cost lower is to test for improvement. And in this test for improvement, we will consider the vacant cells. We will check if we place some units in the vacant cell. We will test if the total transportation cost will get lower. And we will do that in the next lesson. For your practice, please try the following exercise. prepare the initial distribution plan. And that means you have to make the initial distribution from this given transportation table or given transportation problem. Again, as I told you earlier, before proceeding with the solution using the stepping stone method, you check if the given transportation problem presented in tabular form such as this one is a balanced or unbalanced transportation problem. And how do you do that? You get the total of the demands and you get the total of the supplies. If the total demand is equal to total supply, then the given transportation problem is balanced. And you can go ahead and proceed with the solution using the stepping stone method by making the initial distribution and preparing the initial distribution plan. And from that initial distribution plan, you add the totals in the last column and you will get the initial transportation cost. And for you to be able to check your answer, I give you the answer from the initial distribution plan. The initial transportation cost is 5,319. That is the total, the sum of the totals in the last column of the initial distribution plan. But the solution of our first example of transportation problem is not complete yet. We have only made the initial distribution of the supplies to the demands and we have only prepared the initial distribution plan. And as I said earlier, we will do the test for improvement by considering the vacant cells to determine if we can make the initial transportation cost lower. And why do we consider the vacant cells? Because it might be better, for instance, to place some units in this cell with a lower transportation cost per unit, lower than 13 and lower than 10, 9, and 12. If we place some units in this vacant cell, we might get a lower transportation cost. And that's what we will do in the next meeting. We will continue with our first example of transportation problem. And after we do that in the next lesson, you will continue with your exercise. And that completes our lesson for today. If you have a question about the lesson today, you ask your question in the comments below. And don't forget to subscribe to my YouTube channel, Art Calism, the channel of learning and leisure. Or you may ask your friends from other schools and even your neighbors to subscribe to my YouTube channel so they may learn as well. Thank you for joining me in my class today.